In this example, we'll show you how to consider the stress concentration factor in your stress calculations. Now, if you remember, we calculated all this stress before for this example to provide the stress strain examples earlier. So the calculated stress for this piece, the normal stress, was calculated 15 ksi. We can just carry them from the earlier calculation. Now this was without the stress concentration factor. Anytime you have some kind of break in the surface, for example these holes, then it creates more stress than what is calculated just by using that formula, stress equal to force by area. So how to account for that? So whenever you have any kind of break in the surface, then you have to find that stress concentration factor. So it's not, you shouldn't use just the regular formula. You have to find the stress concentration factor. So this is the table that is available in most books. So if you have a circular hole like this, then you try to see the so in this case we have this hole diameter was 4 inches was the hole diameter, and then so basically that's 2r, so 1r would be basically 2 inches, and then the value of d is sorry about that, value of d was 4 inches. So r by d, that's what we need to calculate. So this is r by d. We need this stuff. So r by d is basically 2 by 4. So r value 2 by 4, which is 0.5. So if we can follow this line, so this is where the circular hole lines, and then just follow there. So it's about 1.165, sorry, 2.165 or so. So let's for 2.7, 2.6, anything around in that area. So if we go all the way up now to calculate this, so stress now considering with the stress concentration factor, file is getting slower because of this. It's probably few megabytes now because of this writing. So the formula for stress with the stress concentration factor or K factor would be the K value times the stress without the stress concentration factor, which you already calculated. So we have calculated the K vector 1.16 times the stress without the stress concentration factor. Let's get this. So 15 times 2.165, 15 times 2.165, so I get about 32.5 approximately. So that is 32.5 ksi, 1000 pound per square inch. Now will this section break if we don't consider the factor of safety? The answer would be no, because the yield strength we have seen before for stainless steel was 40 ksi, and the ultimate strength was found from the appendix was 50 ksi. Both of them are higher than 32.5. so if we don't consider the factor of safety, it will not fail. So we can say here not fail. Now if we consider the factor of safety, then it might fail. So let's calculate the allowable stress. So allowable stress sigma is equal to the ultimate strength divided by the factor of safety. Ultimate strength is 58 ksi for stainless steel, can be found in the appendix, and the factor of safety is 3 if we use ultimate strength for normal condition, if there is no specialized thing. So if we calculate this, I think this was calculated 19.33 if I remember correctly for the earlier problem, this many ksi. Now it crosses the allowable limit, so the stress calculated go over the allowable stress. So now that means it's gonna fail. So by considering stress concentration factor of safety, this piece will eventually fail. But in a lot of other calculation, we decided it's not gonna fail. So that's one of the thing that is stress concentration factor accounts for. Sometimes some design may look okay, but if you consider all that, then it might fail.